so we're going to start with logarithms today. And you guys haven't heard that word before, right? Logarithm? I don't think so. Okay, fun. All right, so let's talk about what a logarithm is. All right, so suppose, all right, let's talk about powers of 2. Suppose I have 2 to the power of 1. Okay, I know that that gives me a 2, right? Now let's increase that exponent. 2 to the power of 2, what do I get? Okay, 2 to the power of 3, what do I get? 8. Okay, so take a look at what happened. In going from 2 to 3, right, the value increased from 4 all the way to 8, right? Just by increasing the decimal by by the exponent by one number, right? What did I do? I skipped over all the numbers from 4 to 8, like 5, 6, 7, 8, and so on, right? What if what I really wanted was the exponent that would give me a 6? What if I was interested in what is the exponent of 2 that would give me a 6? In other words, 2 to the power of what is equal to 6? Because when I went from 2 squared to 2 cubed, I jumped over that, right? So what do you guys think? What would that number be? About what, if you had to estimate? Somewhere between 2 and 3, right? Maybe 2.5, something, right? Okay, so that is a logarithm. Okay, so if you were walking down the street and you just saw this on a billboard, you'd be like, oh my God, somebody's looking for the exponent of 2 that would give you a 6, right? And if I was walking down the street and on a billboard I saw this, okay, that's logarithm base 2 of 6. If I saw this, I would say, oh my God, somebody is looking for the exponent of 2 that would give you a 6, right? So that highlighted thing at the top and this is exactly the same thing. So the way I read this is log base 2 of 6, okay? So let me write it to you another way. What is 2 cubed equal to? 8. Log base 2 of 8. So if I saw that on a billboard, I would say, oh my God, somebody is looking for the exponent of 2 that would give us an 8. What is that exponent of 2 that would give us an 8? A 3. Okay, that's what a logarithm is. This is the exponent of 2 that would give us an 8. Okay, so let's take a look here for a minute. Look at this. I have b to the y is equal to x right here. Okay, b to the y is equal to x. B is the base. Y is the exponent. And then x is the value of the power, right? 8, 4, and so on, right? 32. The way we write it in logarithmic form is log base b of x is equal to y, the exponent. All right? So this is the biggie here. The answer to a logarithm is always an exponent. Okay? Just like in this example here, log base 2 of 8 is 3. It's the exponent that we're looking for. So what is the answer to a logarithm? It's an exponent. What is a logarithm? It's an exponent. That you need to know. If somebody taps you on the shoulder when you're walking down the street and says, hey, what is the answer to a logarithm? What do you say? Exponent. Awesome. Okay, so here, let's write each in exponential form. So remember, the answer to a logarithm is an exponent. Every exponent needs a base. What's the base in this equation? The 3 is the base. So it'll be 3 to the power of 2 is equal to 9. If you always go in that order, right, it'll be like infinitely clear. So again, this is the exponent. What's the base? 10. Every exponent needs a base. 10 to the power of negative 2 is 1 over 100, which is true. Here's the exponent. Every exponent needs a base. 3 to the power of 6 is 729. All right? So always go that way. Identify the exponent, that's the answer to the logarithm, and say, okay, every exponent needs a base. Find the base, and then you have it set. Okay, so here, let's write these in logarithmic form. Okay, so here is the exponent. That's going to be the answer. And this is the base. So it's got to be log base 5 of 125 is equal to 5. Remember, the answer is the exponent, always, okay? So, 3. Okay? So 5 to the power of 3 is 125. All right, so here, log base what? 27 of what? Is equal to? Good. Log base what? Of 1 over 216 is the exponent. Okay, the answer to a logarithm is always an exponent. All right, so here, evaluate. Evaluate means find the answer, but we just said the answer to a logarithm is an exponent. So what exponent of 2 gives you an 8? It's as simple as that. What exponent of 25 gives you a 5? Okay, so 25 squared is not 5, so that's not it. 25 to the negative 2, that's 1 over 25 squared. That's not it either. What I'm looking for is 25 to the power of what gives me 5. So here's the question for you. What can I do to, and it's not by dividing, what can I do to 25 to get a 5? Square root. What square root in exponent form? 1/2. So this is 1/2, because 25 to the power of 1/2 is equal to 5. You see that now? Okay, what do you think? Log base 4 of 64? Come on, you guys know. 4 to the power of what is 64? 3. Okay. -2. -2. Good. 6 squared is 36, but 6 to the power of -2 is 1 over 36. Okay. 1 over log base 1 over 9 of 1 over 81. It's just 2, right? Because 1 over 9 to the power of 2 is 1 over 81. So take a look at what happened here. When we went between a whole number and a fraction, the answer was negative. But when we go from fraction to fraction, no need for a negative. Okay? All right. Log base 10 of, how much is that? 100,000. So 10 to the power of what is 100,000? 5. It's the number of zeros. 1, 2, 3, 4, 5. All right? Okay. So where is this used? There are many places where this is used. One of those is the Richter scale. What does the Richter scale measure? Earthquake intensity. The increase in intensity between each number is 10 times. So for example, if you have a magnitude of 3 versus a magnitude of 4, yeah, to you it's one number, but really, to go from a 3 to a 4, the earthquake has to be 10 times as intense. So the difference between a magnitude 3 and a magnitude 5 is it's 100 times greater in intensity. It's exponents of 10, all right? So an earthquake with a rating of 7 is 10 times more intense than one measuring 6. So suppose, okay, the intensity of an earthquake can be modeled by this, where X is the Richter scale rating. Whoops. Okay, the largest recorded earthquake in the United States was a magnitude 9.2 that struck Prince William Sound, Alaska on March 28, 1964. Use the information to find the intensity. So What is intensity, X or Y? Y, right? And then it says this had a magnitude of 9.2. Magnitude is the Richter scale rating, so that's X equals 9.2. Okay? So the equation we're given is Y equals 10 to the power of X minus 1. Y equals 10 to the power of 9.2 minus 1. So Y equals, go ahead and plug that in. What do you get? 10 to the power of 8.2. Is it a big number? Really big? Really, really big. Okay? So that's how big a number it is. How many million is that? Right. 158,489,319.246. Huh? Okay. So now write an equation in the form log y equals log base 10 of x plus c for the inverse of the function. Okay, things just got complicated, right? So now we're all sorts of confused. Okay, fine. So what do? You search for things that you know how to do. One thing that you absolutely know how to do is find the inverse of a function. The function that we're talking about is the function that was given to us at the very beginning. Okay? So lots of times when you're taking math classes, you're just going to be given like random problems that you're just like, oh my God, like they all came out of left field. But you have to know it all is based on something that you learn. So you sift through for things that you know. All right? Now, we know how to find the inverse of a function. What is the first step in finding the inverse of a function? Switch x and y. Good. So x equals 10 to the y minus 1. All right? Now, all of a sudden, we have an exponential function. To solve any exponential functions, we have to rewrite in logarithmic form. Okay, what is the answer to a logarithm? Exponent. So log base what? What's the base here? 10 of x equals the exponent. Do you see how I orient myself? The answer to a logarithm is always the exponent. So I save the exponent for the answer, log base, and then this is the one that I haven't even touched yet. Okay, now what are we going to do? Okay, so now you're like, okay, fine. And then you're like, wait, what is the question even asking me to do? The question is saying write an equation in the form of y equals log base 10 of x plus c. Oh my God, I'm almost there. I just have to solve this for y. How do I solve this for y? What do? Add 1 to both sides. So I get that y is equal to log base 10 of x plus 1. And I'm writing them out separated like that. Normally I wouldn't, just to reinforce the point that log base 10 of x is 1 unit, plus 1 is another unit. They don't add to each other, okay? And so now I need to write it as inverse form. So this is equal to log base 10 of x plus 1. How cool is that, right? Pat on the back for doing that, right? Come on, why aren't you guys as excited as you should be? Right? So exciting. We're building on what we learned last chapter. Yay. Okay, should we move on to 7.4? 7.3 was harmless. Let's see what what could go wrong, okay? Let's see. Okay, we're going to solve logarithmic equations. Fine, we can do that. Okay, let's go back here for a minute. What did we see? We started with this function. This is an exponential function, correct? We found the inverse and it became a logarithmic function. This tells us exponential and logarithmic functions are inverses of each other, all right? So now look, if you had an equation like this that you had to solve, 3 times x equals 9. What do you do to solve this? You do what, huh? You divide by 3. Why? Because division is the inverse of multiplication. So no matter what equation you have, to solve it, you got to do the inverse. We just learned exponential and logarithmic are inverses of each other. So to get rid of one, you have to use the other. This is a logarithmic equation. It means to solve it, I need to apply some sort of like exponential function situation. Okay, what is the answer to a logarithm always? Exponent. So this is the exponent. Every exponent needs a base. What's the base? 8 to the power of 4 over 3 is equal to x. Oh my God, I literally just solved this equation, right? But I got to simplify it. So x is cube root of 8 to the power of 4. You see why we do chapter 6 before we do chapter 7? So how much is this? 2 to the power of 4, 16. Is it warm in here or is it just the logarithms? What do you think? It might just be the logarithms. Okay. All right. This one. How am I going to write this? X equals base to the power of the exponent. Okay. So x is root 16 to the power of 3, 4 cubed, 64. Isn't this fun? Right? Come on, say it like you mean it. Yay! Okay, so exponent is what in this problem? 5 over 2. So x to the power of 5 over 2 is equal to what? Okay, how do I solve this now? How about if I raise this to the power of 2 over 5? You guys know this from last chapter. You just forgot. Remember? So raise this to the power of 2 over 5. So x is 5th root of 32 cubed 8. All right? No, it's not. Squared. Oh boy. So 4. Okay. All right, next one. What do we do? 1/2 is equal to what to the what? 8 to the x. Oh boy. Now that's a problem. What am I going to do now? Okay, so is there a common base? 2. 2 is the common base. So 2 to the minus 1 is 2 cubed to the power of x. Remember doing this? Yes. So now negative 1 is 3x. So x is negative 1 over 3. The base here was 8. But then when I rewrote this, I realized this half and this 8 can be, they have a common base of 2. Right? So this problem is now gone. Now I have a fresh one in front of me. Okay? All right. Lastly, property of equality. All right. If you have 2 identical logarithms, then you can set their insides equal to each other. All right? So take a look here for a minute. You have log base 4, log base 4. Okay? This only works because they're both log base 4. What you can do is you can set their insides. These are called the arguments. If you're ever on Jeopardy and this comes up, on-air credit, right? This is the argument of the logarithm. So we get x squared equal to, yep. So now x squared plus 6x plus 8 equals 0. Oh my God, our favorite quadratic equations are back. They never left us. Had they ever left us? I don't think so. So how do we solve this now? X plus 4, x plus 2 is equal to 0. So x equals negative 4, x equals negative 2. Okay. Now, There is a little bit of an issue though. You guys ready for the issue? There's always an issue. Isn't there always an issue? You have to plug it back in. You have to plug it back in to check. All right? So x equals -4. We get log base 4, 16. Is this equal to log base 4? What do we get? 16, so it works. Okay? Go ahead and check if -2 works. It does? It does. So x equals -2 also works. So those two are the answers. All right? You are never allowed to have a negative number inside the log. Okay? So you can never have, let's say, log base 5 of -2. That never works. Okay? So that's one thing you need to watch out for. All right. So here, log 5 are the same. We set these equal to each other. Let's solve them. Does that factor? X minus 5, x plus 2, x equals 5, x equals -2. So let's check. X equals 5, I get log base 5. 25 minus 10, that's 15. Log base 5 of 15. Okay, that works. Now let's do -2. I get log base 5 of what? 4 minus 10? Yeah, that doesn't work. Okay, that's out of domain. So just say, you don't have to say that, but we throw that one away. The only answer is x equals 5. Okay? All right, questions? Ariella, question? Confusing? Yes. Just a bit. Okay. Huh? Wait, start your question again. Yeah, that's what we did. That's what we did, because look, I took the 5 and I put it here. So 5 squared, right? But you have to do it inside the log, not here. You have to do it inside the log. Okay? Now this one, we could have also figured this out like a mile away, because on this side, we can't have log of -6 either, right? So that would have failed. Okay. All right. So take a look at this one. We're going to solve this one for m. Okay. So to solve for m, first I got to get rid of the 15. So I do plus 15 on both sides. N plus 15 is 7 log base 4m. Okay, what do you suggest we do next? Divide by 7. So n plus 15 over 7 is log base 4 of m. Now what? Huh? We got to change it to exponential form. Where is the exponent here? N plus 5 over 7. Every exponent needs a base. What's the base? 4. So 4 to the power of this lovely exponent, okay, n plus 15 over 7 is equal to m. Okay? Yeah, right? And that's okay. It can look like that. That's totally fine, right? And there we go. That's 7.3 and 7.4 for you, right? All right.